This video is going to be about the water cycle, hydrologic cycle, and groundwater. And I'm going to talk about the basics of each of those. So let's start with this diagram of the water cycle. This is a cycle that you've seen before, and it basically is telling us how water is moving on the earth, above the earth, and below the earth in a continuous cycle. So water gets recycled through this process. There is no new water on earth. Water is not created or destroyed. Just like all matter on earth, there is no new water that's created or destroyed in this cycle. So the water that you're drinking today is the water that's been on earth for billions of years. Just keeps getting recycled. There are different parts of the water cycle that we're going to talk about. We'll talk about condensation, evaporation, evapotranspiration, precipitation, and we'll certainly talk about the groundwater. So if you want to pause, you can. There are some definitions here from the water cycle that you should know. Of course, evaporation is changing from a liquid to a gas. Precipitation is the falling of water from clouds in the form of rain, sleet, snow, hail. Condensation is the process of turning a gas into a liquid. Transpiration is the process where water moves out of plants. And evapotranspiration is when water from plants and the soil basically moves into the atmosphere. So I want to show you some evaporation first of all. In a little teacup. So you can see the steam. So that's evaporating. That's water that's evaporating into the atmosphere. So that steam is going from basically from a liquid into a gas. Right? So that's evaporation. And I've got an example of condensation here. I don't know if you can tell, but the bottom of this napkin is wet because this glass is sweating. There's ice in it, and get a close-up view for you, and I think you can see the particle, the water condensation on the side of this glass. So that's condensation. As the water that has air in it hits this cold glass, and the molecules slow down enough so that they turn back into a liquid. So that's condensation. And then I've also got some plants here in a little planter. And I don't know if you can tell, but there's a little bit of water on the top of this lid from the process of transpiration. So you can see the water on that. And that was from just these plants giving off water. Okay, so that's transpiration, process of transpiration. All right, so they call the Earth the water planet, or the blue planet. So here's a picture of the Earth. And as you can see, most of it is water. 97% of the Earth's surface is made up of oceans, okay? Salt water. 3% is fresh water. Now, of that 3%, 2% of it is frozen, as in glaciers, and 1% of that is available to us to use. Now, of that 1%, most of that water is groundwater. So what is groundwater? Again, pause it if you need to. It's water that moves through spaces in rock and sediment underground. It's an extremely important freshwater source. It is not like a river or a lake underground. Okay? Groundwater is found in an aquifer. An aquifer is rock or sediment layers where water can flow or be stored. So think of a sponge. So here's a sponge, and it's got pores in it, and those little spaces can hold water. Okay, so that's what an aquifer is like. Think of an aquifer as a rock layer similar to a sponge. And the water can flow through that aquifer, okay, through that solid rock. The flow of the water through the aquifer depends on its porosity and its permeability, and we will be talking about that a little bit later in a different video. All right, well, what does this groundwater look like? We're going to draw a picture. And if you want to draw this with me just to get it down, you can. And grabbing my writing utensils, sorry about that. All right, so here's a house, and we're going to kind of look at it as if we can see into the ground. So we're going to dig down into the soil, digging, 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 and pretty soon we get to something called the water table. So there's this boundary where you hit water, and that line that I just drew represents the top of the water table. Okay, the top of the water table. Everything below that line is the aquifer, so it's like the sponge, okay? And it's filled with water. Those pores that are in that rock layer are filled with water, saturated with water. So they call this, first of all, it is an aquifer because it's storing the water, okay? But they call this whole area below the water table, they call this the saturated zone. And everything above that layer does not have water in its pores, and so we call that layer the unsaturated zone. All right, so the pores that are up here are basically filled with air, and the pores down here are basically filled with water. All right. We also call this layer the unsaturated zone. It's also known as the zone of aeration. Think of air because air is filling those pores. All right, so if we could zoom in on what the particles actually look like in our picture, we would have something that looks like this. So let's zoom into the one right at the water table. All right, so here's the water table, this line. Everything below it is water, and if we could zoom in on the particles, these are the sediment particles, maybe clay or gravel or something. And in between the pores down here, it would be filled with water. And on top of it, that would be air, because above it is the zone of aeration, or the unsaturated zone. Here's the saturated zone. If you looked at the particles below the water table, their pores will be completely filled up with water. And if you look above the water table, depending on like the season and the weather and things, the air spaces might just be free of water altogether, and that would be the sign of a drought. Okay, but normally there is some water particles clinging to these other larger sediments. I mean, think about it. Plants have to put their roots down into the soil and get some water. So this is what it might look like normally, with some water droplets clinging to the particles. Okay? All right, so that's what it would look like if you could zoom in on the pore spaces. Now, what would this look like in more of a forest type picture? So here's a picture of a forest, and you can see that all of this is an aquifer, and you can see a couple of zones. All right, we've got our unsaturated zone, which is above this dashed blue line. That's our water table. This is the this is the saturated zone below it, so it's saturated with water. Water table here, unsaturated zone up here, also known as the zone of aeration. If you follow this picture over to the right, there's a lake. Now, when you see surface water, that surface extends into the ground. that is where your water table is. Okay? So if you dug down right here, you'd hit water. Water table can be deep or it can be pretty shallow, as in this picture. All right, well, let's look at another picture with a little bit more detail. You've seen something like this. Okay, so they're showing you some rain coming down on the scene, and that rain is going to seep into the ground and go into the groundwater below. All right, I added an impermeable layer to our picture here, and this number 2 is an impermeable layer as well. All right, and what that does is it puts these aquifers under different kinds of pressure. So this number 7 is a well that somebody dug, a pipe basically that goes all the way down into this aquifer, and it stops right before the impermeable layer. So the opening to this well is still in our aquifer. Okay, so you can turn this well on and you would get some water out of it. The one that's over here as number 9 is under more pressure because it's sandwiched. The opening to this well is sandwiched between an impermeable layer below and an impermeable layer above it. So that puts pressure on this number 5 aquifer. And so that would be a well that's just like a fountain or flowing. They call that an artesian well. Okay? A couple other things to know about this is that if you do get a lot of rain, lots of precipitation, this water table level can rise and get closer to the surface of the earth. So the water table can move up, and the water table could certainly move down if there's not enough rain. Okay? All right, so another diagram to look at. Let's look at lots more going on in here. All right, so I got my surface of my earth. I've got some trees in here because I just wanted to remind you that the roots here do go below the surface into the zone of aeration. And yes, there is some water in between the particles. It's just clinging to the particles like we showed. So you can get some water out of this. All right, this soil is not 100% dry, as you know. When you dig into the earth, it's not completely dry. So they call it the zone aeration because the particles are for the most part filled with air, but there is some moisture within. All right, I've got 3 wells that are dug here, A, B, and C. A ends here in the zone of aeration, B goes all the way down into the aquifer, and C goes all the way down an impermeable layer, something like clay, which is impermeable. So it goes below that layer and it's in another aquifer. It's called a confined aquifer because it's underneath that impermeable layer. All right, so I got 3 wells, and let's talk about what might happen here. First of all, if you tried getting water out of A, you're not going to get any because it's in the unsaturated zone. B is going to supply you with some nice clean water, and certainly C will supply you with some nice clean water as well. But what happens if somebody spills, there's like a big toxic spill, like somebody's oil tank or something like that. Maybe they have oil heat for this little cabin, and the whole tank just leaks, and all of the oil kind of filters down into this zone of aeration, keeps going, and if there's enough of an oil spill, it's going to get all the way down into your aquifer, and then that oil can contaminate your well, and that actually does happen. People's wells get contaminated with pollution, and that's a very serious thing. All right, well, if they were lucky enough to have well C as well on their property, that would not be contaminated, because if that oil keeps filtering down, it's going to get to this impermeable layer. It can't go through the impermeable layer. So this water is fresh and clean. So this family would want to use well C if there was indeed an oil spill. Okay. Now, what if we have many people using these wells rather than just one person? So let me find my picture, sorry. So what if instead of just one person using the well, we have other people starting to move in? And I'm going to say that this is going to represent a house, and here's a house, and here's a house, and so on. So let's say that I've got lots and lots of these new houses on the property, and everybody needs water. And they're either going to be using your well, maybe they're going to hook up, pipes to that well. Maybe it's like a city municipal well. So they're all using the same well. Or they might decide to drill their own wells. Regardless, a lot of people are going to be putting their houses up and using water. And if they're all using the same aquifer, what's that going to do to the water table? The water table is going to get lower because they're all using this aquifer, right? Whether they're pulling it out of B or they've drilled little tubes, their own pipes, their own wells all the way down. So they're all using the same aquifer. All right, let's assume that they're all using this aquifer. That means the water table is going to lower. It's kind of like what would happen if 3 people were trying to all use straws from the same drink. It's going to lower the level of the drink very quickly. Okay? So, last but not least on this, I would like to show you a little quiz. And you can pause the video and see if you know the answers to these things. All right? So take a look at where all the letters are. So this is a side view, all right? And you got a blue line that goes all the way across here. That blue line is D. This green is all letter C. All of this brown is letter E, and all of this dark brown is letter F. So pause the video and see if you can identify all of these. And here's your answer key. And how did you do? Alright, that's the end of this video. I hope you enjoyed it and watch it over and over, take notes on it, learn it. Thank you.